everybody, this is Ms. Makano, and today I want to talk to you guys about correlations of variables. So we've been talking over the past few weeks about different kind of variables. We've been talking about independent variable, dependent variable. When we're running an experiment, the independent variable being the variable that we are purposely manipulating or changing in order to see if it has an effect on the dependent variable. So the dependent variable is the one that we are measuring to find out what effect the independent variable had on it. We talked about a bunch of other types of variables as well, control variables, but right now I want to hone in on the independent and dependent variables. And we've also been talking about how to create data tables and graphs to show us if there are any relationships in between these variables. So today we're going to pick up from there, and we're going to talk about correlation of variables, meaning how do we know if there is a relationship in between two different variables. So for example, in order to find out if there's a relationship between two different variables, we need to make a graph. And a lot of times the graph that will work the best for that purpose would be a scatter plot. And we're going to see some examples soon. So here are some examples. Let's say we wanted to know if there is a correlation or a relationship between shoe size and height. So how would we know that? Well, we would make ourselves a graph, maybe something like this. So we would have always our dependent variable. So dependent variable would always go on the vertical axis, and independent variable always goes on the horizontal axis. In this particular example with shoe size and height, I want to put the height is my independent variable. So that would go on the x-axis, horizontal axis. And then my shoe size would be the dependent variable on the vertical axis. So what would I expect to see for this? Well, intuitively, if you think about it, the taller a person is, so the taller they are, the more I go to the right on this axis, the more I would expect their shoe size to increase. So I would expect that maybe a person that has this height over here, let's say they have a shoe size about here, so that would be my data point for them. Then maybe somebody else is a lot taller and they have this height over here. Let's say this was 5 feet. Let's just put some numbers on it. 5 feet tall, and their shoe size, let's say, is shoe size 5.5. And let's say we got somebody who is 6 feet tall, and their shoe size maybe is going to be closer to 7. So they would be, I'm going to plot this like this, so they would be around here. And then let's say I have somebody who is, well, I don't want to say 7 feet tall, but let's say they're like 6.5 feet tall, 6.5 feet. And their shoe size, I'm going to say, is like a 9. So it's somewhere around here. All right. So I can see that if I plot these points that I just plotted, if I draw a line through them, it's going to give me a line that goes up like that. And that is kind of what I would expect. The taller a person is, the more their shoe size will increase. So that's one type of relationship. How about hours of driver training and number of accidents? Would we expect that as somebody has more and more hours of training, so let's say this is hours of training, and this is number of accidents, would we expect that as people have more training, more driver training, they would get in more or less accidents or have no effect on the number of accidents? Well, I think it's it's pretty clear that if the more training we have, the less accidents we tend to get into. Okay, so in this case, I would expect to have what we call a negative relationship. The more hours of training we have, the less accidents we're gonna get. So something, maybe a line that goes like this. So when you have very few hours over here of training, we're gonna tend to get into more accidents. So we're gonna be at this end of the line. Whereas when we have a lot of training, whoops, sorry about that. When we have a lot of training right here at this end of the line, we're gonna tend to get into a lot less accidents. So that, sorry about my PowerPoint, not sure what's going on here, but that is basically another kind of relationship. How about cigarettes smoked per day and lung capacity? Would we expect a relationship there? Would we expect that as somebody smokes more and more cigarettes, their lung capacity would be increased, decreased, or stay unaffected? And I think if we know anything about cigarettes, we know that the more we smoke, the worse our lung capacity is. So again, in this situation, we would expect to see something where the more we smoke, so this is cigarettes over here, and this is, let's say, lung capacity up here, our dependent variable on the vertical axis. We would expect that when you don't smoke any cigarettes, your lung capacity is great, but the more you smoke, the lower your lung capacity goes. And again, this, and we're going to talk more about this in the next few slides, but this would be a negative correlation because the more the cigarettes go up, the less the lung capacity is going to be. How about a score on the SAT and grade point average? Would we expect that the higher your GPA is in, would you expect any relationship, first of all, in this? And if so, what kind of relationship? I think from our own experience, we probably know that the higher your GPA is in school, you're going to probably tend to score better on the SAT. Okay, so maybe we would expect something like this, where let's say this is your GPA right here, and this is your SAT score. So you would expect that if your GPA is really hurting, you probably would not expect to have such a great score on the SAT either. But as your GPA increases, your SAT score you would expect would reflect that, and it would be a better score as well. And finally, let's go through this one, height and IQ, and let me go to the next page so we can do it over there. So height and IQ, would we expect any kind of relationship in between these two variables? So if I were to put height, a person's height over here, and then IQ over here, if I measured height and IQ in a group of people, would we expect any correlation? And height has nothing to do with our IQ. So we probably would see some data that is all over the place, like this. We would see no correlation, basically. Okay? So we would see that regardless of your height, regardless if you're 4 feet tall, 5 feet tall, 6 feet tall, your IQ, we wouldn't see a line going this way, we wouldn't see a line going that way. We would see some kind of like a cloud of scatter points like this, meaning that your IQ could be anywhere in the range of IQs that we see. All right, so that would be when you see a cloud like this of scatter points and there's no clear trend line, that would be no correlation. So let's go a little bit more through this and see more specifically, because you're going to be asked to do this on your assignment and on the test, you're going to be asked to determine if there is a correlation, and if so, what type of correlation and how strong is it? So here are the kinds of scenarios you're going to see. And let's talk about what are we looking for. Number one, you're going to be looking for if there is a correlation, is it a linear or non-linear correlation? What does that mean? Well, that means you got to look at the trend line. So for example, if your trend line is a line, like in this situations right here, we see that the red trend line going through these blue data points, we got a red line. That's the trend line. We got another red line in this scenario, the second scenario. That's also a trend line, okay? However, in this scenario over here, we have a U-shaped curve. And so in these bottom scenarios as well, we don't have a straight line. We have some type of a curve that fits the data points. So if we have a line, if our trend line is a straight line, then we can say that we have a linear relationship. If our trend line is not a line, as in this example where we got sort of parabola, and over here where in the bottom examples where we got some kind of curves, then we have a non-linear relationship. So we call these non-linear relationships. And if there is no trend line, we have no correlation. Like in the example that I showed before, over here, there is no trend, okay? That would be no correlation. Also, in this example right here, I'm not seeing that a line going up or going down, so there's no correlation. The second question we got to ask is, all right, now that we know whether we have a linear or non-linear correlation, is it a positive or a negative correlation? In order to answer this question, we have to look at the slope of the line. So if we have a positive slope line, meaning it's going up to the right just like this, like in this scenario right here, that would be a positive correlation. In this scenario here, we also have a line going up to the right. That is also a positive correlation. If we have a negative slope on our line, for example, this right here, the scenario right here where our line is slanting down, or this example over here where our line again is slanting down, that would be a negative slope, meaning negative correlation, okay? The third question we're going to ask ourselves, is it a weak or a strong correlation? In order to answer this question, you have to look at how well the data fits the trend line. For example, let's look at this first scenario over here. We see our trend line in red, we see our data points in blue. Those data points are very tightly clustered around our trend line. They're almost on that line. They're almost touching the line, all of them. That is a strong correlation. In this example below, we have our trend line, but our data points are not nearly clustered as tightly around it. They're much more scattered about around that line. So this would be a weak positive correlation. It's a weak correlation because the data points are scattered, and it is positive because our trend line is still going up. It's still got a positive slope. Same thing over here with our negative correlation. We got a strong correlation in the top scenario where our points are very tightly clustered around that line. Got a we got a weak correlation in the bottom scenario where our points are much more scattered about. And finally, we got to ask ourselves, do we have any outliers? Outliers mean points that are clearly off the line. So maybe in this scenario, maybe I would call this point right here, it seems to be really far away from that trend line. I would call that an outlier. Maybe this point down here, again, very far away from that trend line, that would be an outlier. Let's say I had a situation like this, where I have a nice trend line with really nice data all around it, and then I got one point over here, that would be my outlier, okay? So basically, this is the information that you need to conduct and to complete your assignment, which is on correlation of variables. I look forward to seeing you guys in class, and thank you very much for watching this.